I'm working problem 6 from the review sheet for our exam that's coming up. And problem 6 says, study the following label. How many grams would there be in a 5-day supply of the usual adult dosage? Now I'm going to solve this problem on the video a little differently than I solved it on the written answers to the problem. A little different approach. You can see which approach makes more sense to you, and you could kind of model a similar problem after whichever approach makes more sense to you. Well, if we look at the label, it says cloxacillin sodium is the drug. And we see 250 milligrams, that's in bold print, so that would be indicating to us that that's the normal dosage. And it says right here, usual adult dosage, 1 capsule, 250 milligrams, every 6 hours. And the question was, how many grams would there be in a 5-day supply of the usual adult dosage? So I'm going to start with the 5 days. We're going to be giving the drug to the patient for a total of 5 days. And we want to know, well then, how many grams would they totally get? That's the question they asked. How many grams would there be in a 5-day supply of the usual adult dosage? Well, the usual adult dosage is 1 capsule every 6 hours. So we need to get hours introduced here. So we can get hours introduced from days just by remembering that there are 24 hours in one day. So we can introduce hours with a conversion fraction that uses this equivalence. So I want the days to disappear, and I want to have hours. And again, the reason I'm thinking I need hours is because the usual adult dosage is 1 capsule every 6 hours. So I have to get hours introduced here somehow. And this might be the appropriate time to do that. It's 1 capsule every 6 hours. So putting that equivalence in, I can get rid of hours and get to the number of capsules that the patient would be receiving totally during those 5 days. In fact, if we stopped right here and did this arithmetic, we would figure out how many capsules that patient was going to be receiving during that 5-day period. Because we've gone from 5 days to capsules. Now, I want to get from the total capsules they've taken to the number of grams of the drug that those capsules contained. And so I have to go back to the label, where the label says that 1 capsule equals 250 milligrams. It doesn't tell me how many grams, it tells me how many milligrams. But if I can get to milligrams, I can get to grams, because 1 gram equals 1,000 milligrams. And I can use these two equivalences, I should say, to create 2 conversion fractions that will get me into the unit of measure I want, which happens to be grams. So I want capsules to disappear. So I'll put that down in the denominator. I want to have milligrams. So now if we did this arithmetic, we would be learning how many milligrams of drug in the whole 5 days of administering the drug. And now we can use this equivalence to get from milligrams to grams. Adjust my ending point here. So I want milligrams to go away, I want grams to remain, and the equivalence is 1 gram is 1,000 milligrams. So if I do all of this arithmetic, I would end up knowing how many grams, because milligrams have canceled. I would know how many grams totally the patient received over those 5 days. Well, let's see what we can do for some canceling. Well, 250 will go into itself once, and will go into 1,000 4 times. 6 goes into 24 4 times. Oh, the 4's cancel to 1, leaving me 5 grams. So if we gave the patient 1 capsule every 6 hours of the 250 milligram drug, and we gave that to them for 5 days, we would have given them a total of 5 grams of the pure drug. And again, this is a little different approach than I used in the written answers to this problem, but maybe one of them makes more sense than the other two. I want to show you 2 different approaches so that if there's one that clicks better than the other, you could use that if you had a similar problem of your own to work.